Welcome back, everyone, to SAT Math Question of the Day. Here's our question of the day. Please try it, pause it, come back, and we will try it here. Okay, if 2 to the m is x and 7 to the n is y, which of the following is equivalent to 84 mn? Whoa. Wow, look at that.
Notice, please say M, M,
Yeah,
and
M.
N.
That's right, M and N.
Don't say to the M, to the M. To the M, 7 to the M.
Okay, fine. 2 to the m.
2 to the M and 7 to the N.
Right. The bottom line is you have factors of 784 raised to these m and n factors. So it looks like we're going to have to factor 784 into 7s and 2s. 7 and 2s. So my intuition is 784 is 2 to what? 2 to the a power.
Well, divide it by 2 and
times
keep dividing by 2.
To the b power. So I'm just going to be lazy today. I'm just going to use a calculator because everyone has a calculator on. This is from the digital SAT. Now I'm going to divide by 7 first. I hope you don't mind. So I'm going to hit it with the 7. Oh! It's only to the 7 to the first power because 112 divided by 7. Wow! It's to the 7 to the second power. 7 to the second power. 7. We're just doing a factor tree, sort of. 784 divided by 49 is 16. Okay, and we know that 16 is 2 to the 4th power. So we've broken 784 into it's prime factors, right? Because 2 and
right.
Yeah, okay, we've broken 784 into its prime factors. So now we match this, and we substitute 2. No. 2 is 2 to the m to the 4th power. Right. And see, 2 to the, we're substituting 2 to the m in there. 7 to the n. What am I doing? Wait, hold on. Let me Let me do it. Slow down. 2 to the 4th. 7 squared, right? So this is equal to 7 to the second power. So n is 2. And this is equal to 2 to the 4th power. So m is 4. Right? Okay, good. So slow down. Let me think.
Nothing's wrong.
No.
Going down the rabbit hole.
Okay. I'm going down the rabbit hole. Fine. Okay, we know that
they are not interested in 784. They're interested in 784 to the mnth power.
Oh, right. Okay, so erase all this. You're right.
So don't erase it.
No, I'm going to write
the factorization of 784 is important.
Of course.
So write 784 factored.
Is 2 to the 4th, 7 squared. I was able to memorize that.
Okay. Then raise both
that's
sides
right.
to the mnth.
Right. So that's 2 to the 4th, 7
mnth. Was it 7? Is
7
it 7
squared to the mn?
Yeah, don't forget the square up there.
I got it. So this is 2 to the 4 mn times 7 to the 2 mn. Okay?
Yeah.
So now we have 784. What does that equal?
Yeah, so 784. So match 4 to the mth. So oh gosh. So what do we have?
Now we
2 to the 4 to the mth n.
Times 7 to the mn. Now
x is 2 to the mth.
That's right.
Yeah, so we have 2 to the 4 mn.
Yeah, 2 to the mth is this.
Right.
So it's x equal to 4n.
X is 2 to the mth. 2 to the mth, which is x to the what? And the question mark is therefore 4 to the nth. So it's one of these guys.
Yeah, it's x to the 4n.
4 to the nth. So it's this
it's
one.
this one. Yeah, it's that one.
Yeah.
Yeah.
And I didn't mess with the y. So let's check if the y exponent is consistent.
Right. Yeah, it is. It is. It is. It is. It is. It is. Yeah. So you see, I don't know. I mean, thanks, Seth, for reminding me that it's 784 to the mn power. I would have noticed that eventually because what I was doing wasn't going anywhere. So I would have looked back. So what happens if you have a problem and it's not going anywhere for you? You stop, which I would have done in a few seconds, and I would have gone back to the very beginning of the problem saying, hey, something just is not working here. Go back to the beginning of the problem and find out what you're missing. So then, yeah, once Seth reminded me of that, it just falls right through. I like the substitution here. I don't know, so maybe I'll rewrite it. I'll rewrite it a little neater. Gee, I sort of think it's clearer. Substitution is great in algebra. Once you get to this point, it's 2 to the 4 mn times 7 to the 2 mn. But they're telling us that x is 2 to the m. So we take a different color. So this 2 to the m becomes an x. And you're left with 4 to the n. This 7 into the n is this thing. See that? That's to the y. That's a y. And that's left to the 2m power. And then that's the answer. I mean, Seth did a similar thing down here. But he didn't put the x in explicitly. So, I see Seth's going through the prime factorization of 784. Basically, when you see problems like this, you need to, if you see a 784 and 2s and 7s floating around, it's very likely you're going to have to do a prime factorization of 784 to get it in terms of 2s and 7s.
Well, let's also, we need some of the points of this problem, the approach that you need to follow.
Yep.
To pay attention to certain details.
Yeah.
Like they are asking not about 784, but
right.
about 784 raised to the mnth power.
Well, actually,
second, these two distractors, these two answers, the answer we think is correct, and the distractor differ in a way that's prone to making mistakes. What they did was they interchanged the place of m and n.
Yeah.
So you have to be careful about distinguishing your m and n.
Yeah. Right. Right. Yeah. Yeah. Yep. Yeah, I was going down the rabbit hole because once you have this prime factorization, this right here, the 2 to the 4th 7 squared, really has nothing to do with x and y yet. They have nothing to do with x and y yet. I mean, you could do it sort of, but it would be very difficult.
What they have to do with x and y, and the prime factorization, is that x only has factors of 2.
That's right.
Because of prime factorization.
Yep.
And y only has factors of 7.
Right.
And therefore, when expressing any other number in terms of products of x's and y's, which is what you have, x here are there 2m 2 times mx's multiplied together. The only factors of this thing in the circle, 2 to the x to the 2mth, prime factorization tells you that the only numbers that divide that power of x are powers of 2.
Right. Yeah.
And the only factors of y raised to a certain power are powers of 7. So this problem, what we do is we need to express every number of which powers of 784 are the numbers in question. We need to consider the prime factorization in terms of factors, in terms of products of 2s and of 7s.
Right.
Yeah. Yeah. That's the idea here. If,
Right.
for example, instead of a 2 and a 7, they had a 2 and a 4,
you'd have a problem.
You'd have a problem, and the answer, this kind of, and the answer of expressing it as a product of 2 different powers, 2 products powers, there might be multiple answers.
Oh yeah. Well, 4 is
if
actually
it
a bad
not for
example.
the fact that 2 and 7 are relatively prime.
Right.
And they're relatively prime because both of them are prime and they are different.
Yeah. Right. Okay. My mistake was I went a little bit too fast, and I didn't read the question right. So I tend to do that, unfortunately, as people have seen on these videos. Probably a normal person. So try to make sure you read the question and see what they're asking. But eventually, we all, including me, would have figured that out. Okay, and then to prime factorize, there are different methods. You ever heard of the birthday cake method or the upside down birthday cake method? It's taught in middle school. I'm not all that knowledgeable on it myself, but the best thing to do is do what did Seth do? Oh, he divided by 2 first. I would try to divide by the higher number first to get the number down as quickly as possible, rather than dividing by 2 is easy, but you have a calculator. So I would hit it with the highest numbers first. Divide 784 by 7, you get 112. And then you hit 112 by 7. Who would think 112 is divisible by 7? But it actually is. And then you get 49, and 49 is 7 squared. And then you divide 784 by 49 to get 16. Again, you have a calculator. And you know 16 is 2 times 2 times 2 times 2. Where 16 is 4 times 4. And 4 is 2 times 2. And 4 is 2 times 2. So it's 2 to the 4. Okay, so should we look at how they did it?
Yes, okay.
Okay. So let's clear all drawings. And it's sometimes nice when you're doing factor trees to be very neat about it. 784 is 7 times 7 times 2 times 2 times 2 times 2. That's very nice. And then you can see it as 7 squared, 2 to the 4. Okay, that's a very nice thing to write. Okay, that's probably how they did it. Well, we'll see. I'd not be surprised if they have that exact text there. Okay, here we go. Okay, let's see how we answered the question. 4 steps, okay. I see. They eventually wrote what we had at that first step. I don't like red. So they had this. And then Seth brought this in. Critical thing, right? Then you have to use the power rule. This is called the power rule. Very, very important. Exponent rule. Ultra important. And you distribute. Power rule is sort of on steroids. You distribute the M to both of them. Okay. So then you get this.
Well, let's see. Why about the power? We have A times B times A times B times A times B. A times B.
Right.
And there are M times.
Oh, that's not the power rule.
That is the power rule.
No, isn't the power rule?
That is the power
Wait,
rule.
wait.
And
wait,
so
wait,
in
wait,
this product, there are MAs multiplied A to the M, and they're multiplied by MBs multiplied E to the M.
Right.
So, and now this is A times B. The whole quantity A times B multiplied by itself M times
Right.
is what we mean by putting the quantity A times B in parentheses and put the exponent M.
Right.
So this is the power rule.
Okay, let me ask you a diversion
that
question.
Joel mentioned.
So what do you call this rule? A to the X to the Y power is
Okay.
AXY. So what do you call this rule? I thought I call this also the power rule. Isn't that the power rule?
Oh, yeah. So that's another version. So I'll say that
Oh,
one.
there are two versions of the
You
power
have
rule?
X, you have X, you have a XAs.
Right.
You have XAs multiplied together, and you multiply that together Y times.
Yeah, right.
Y times altogether.
Right.
And now how many A's are there? Well, there are XAs from here, another XAs from here, and so the number of A's is the count of A's in each factor times the number of factors. So that is the total number of A's is X times Y.
Right.
Equals the number of A's.
Yeah. Yeah. Sometimes it's easier to see it. 2 cubed, 2 cubed to the second power is 2 cubed times 2 cubed. Okay, which is 2 to the 6th. Or if you also want to do it, just 2 times 2 times 2 times 2 times 2 times 2. There's 6 of these things, right? There are 2 cubed here, 2 cubed here. You add them all up, you get 2 to the 6th. So you can see it with a little example. Oh, they're both called the power rule. I guess you're right. I guess they are both called the power rule. Oh, okay. So anyway, first we know, okay, now why don't we erase so we can see how they do it. So this is all derivation of the power rule, which we don't really need right now. We've been there, done that. So, and to be fair, I'll erase my stuff here too, and this too, because it's not as important. Okay, so what have we got? Okay, first we note that we're able to go from the second step to the third step using the commutative property. Okay, fine. Okay, also note there's a desirable form of the expression since we're given this. Substituting, yes, substituting. We change the 2m to the 4n as 2m to the 4n. Right, that's the opposite. Oh yeah, this is the opposite of the thing that I just mentioned. X a to the b is x to the ab. You can actually switch that around. This is xb to the a. Isn't that nice? That's what they did. And then sure enough, this is x and this is y. And that's it. So they substituted. But they also used this version of the power rule in reverse. Right. Okay. Sometimes, it's interesting, a lot of people miss, sometimes you use the product rule in reverse, which is very, everyone knows that x to the a times x to the b is x to the a plus b. But sometimes you see problems where you have to use this in reverse, and sometimes people, it's hard to see that. Let's just show that example. You may have like you may have something like this. You don't realize it's product rule in reverse. You have 2 to the x plus 1. 2 to the x plus 1. Interesting. Watch. You can write 2 to the x times 2. See that? This is the product rule done in reverse. And sometimes this is handy to realize. This is equal to 2 times 2 to the x. I mean, this is easier to see, right? This is easier to see using the power rule in reverse. But sometimes the product rule in reverse is really handy. So, okay. What do you think, Seth? You've been uncharacteristically quiet.
Well, I muted my microphone because there was sound in the background, which is still...
Oh, okay. That's funny. Oh, I see. You muted on the computer side, not on the Zoom side, because on the Zoom side we would have seen a little mute. But you're doing it on the computer side. Very nice. Very on the microphone side. Okay, so I think we're done with this. What do you think?
Yes, we're done.
Okay, we're done. Okay, everyone. So this is Seth Chaiken. He has a PhD in math from MIT. He's pretty good at math, and he's a professor emeritus at SUNY Albany. Retired now in computer science. I'm Seth's brother. I have a PhD in mechanical engineering. I sometimes rush through the questions a little bit too fast. And together we're here to show you how to do these SAT math questions. We also suggest a good approach to studying for the math SAT is get a Khan Academy account, which basically comes with your College Board account. And there are 2 courses. There's the digital and non-digital courses. Take one. They offer about 700 questions in math, probably the same in English. And you can study exactly what's on the test because they partner with the College Board. And the College Board basically tells Khan, this is what's on the test. And Khan makes all these questions up. Okay, and of course, practice on actual SATs, digital or non-digital, as the one you're going to take according to your guidance counselor. Okay, everyone, have a great day. Please like us, dislike us, give us comments on our YouTube videos, and if you have any SAT math questions, email them to us at satmathquestionoftheday@gmail.com. Have a great day, everyone.